All right, so my clock shows 17:01, so I guess it's time to begin. Welcome to the Gren O2 pre-release live stream thing that I'm hosting. Um, uh, Before we begin properly, I just want to say this is my first live stream, so it can go well. It can also go horribly bad, seeing I've never done this before. So just bear that in mind. Um, Unexplainable things may occur. Um, also, if you think this, if we all think this turned out great, let me know after a stream, and maybe we'll do this again for the next release. With that out of the way, let's begin. So Gren O2 is now done. Development development on Gren O2 has finished. It will be officially announced on Monday, December 12th. But the release is made. So all the binaries and all the node installers. Well, there's only one node installer, but the npm installer is already available. So if you want to try out Gren O2 after the stream, feel free to do so. Everything's ready. We're just waiting for the release announcement to go out on Monday. So the plan for this stream is to just give a brief introduction to Gren to those who haven't really heard much about it before. Gren is almost a year old at this point, or year old. It was forked about a year ago from the Elm compiler. So we're going to go through a little bit about what Gren is, and most importantly, what it isn't. And then we're going to talk about what's new in Gren O2 before I'm going to try to hold a live demo where I'll build the echo Unix command in Gren. If that goes well, or even if it doesn't, I'll start talking about what I hope to do for Gren O3, and then we'll round off with how you can contribute to the Gren project should you want to do so. And depending on the time, I'll also try to answer some questions at the end. So first off, what is Gren? It's a pure functional programming language that aims to be easy to learn and to reason about, while remaining powerful and portable enough for real world use. That's the catchphrase. That's the slogan. In practical terms, Gren is a fork of Elm with a goal of supporting command line applications and backend applications without sacrificing all the aspect that makes it a great front-end language. But it's important to keep in mind that Gren isn't Elm. It's not supposed to be Elm. It's not supposed to be compatible with Elm, and it's not going to track. Like if a new version of Elm comes out tomorrow, Gren is not going to try to follow that release in order to stay more compliant with it. Gren is very much his own thing, and really the only reason I forked Elm is so I didn't have to spend 2-3 years to build my own compiler. It's a cost saving measure mostly. So that's important to bear in mind. That being said, another reason for forking from Elm is because Elm is very, very close to what I consider the ideal programming language. I just want to be able to write backend applications with it. Gren 01 was released in early June, and it was mostly the release that just said it was mostly just a release to let people know that Gren is a thing, and you should watch this space. So the most important thing about the Gren 01 release was the name change, that it had a rewritten package manager that could stand on its own, and it also removed a bunch of features that I personally don't see the need for, like the reactor, the shading language syntax, and tuples. It also removed automatic constructors for type alias records. It uses JavaScript arrays instead of lists, and it has improved pattern matching on records. And that's really it. Other than that, it's exactly the same as Elm, even down to the core packages that are available. So what's new in O2? The big ticket item is support for building applications that run on NodeJS. And I'm gonna show a live demo of that in just a little bit. Another huge addition in O2 is the addition of a built-in code formatter. This has largely been contributed by Aaron Vonderhaar. I hope I was pronouncing that right. He started working on this even before O1 was released. And I'm super excited for people to start using that code formatting. I know I missed code formatting a lot. Another big thing is package consolidation. It's not really a big feature, but it's definitely something that you will notice. The package manager has also been improved in almost every conceivable way. And finally, there have been a few quality of life changes to the language itself. So we're going to go dive a little bit into the most important changes. So a big change in Gren O2 is the notion of platforms. So when you define a new Gren project now, you also need to define what platform you're targeting. And there are 3 platforms to choose from. There's the common platform, the browser platform, and the new Node platform. The platform essentially decides what dependencies you can use in your project. So a project that targets the Node platform is only allowed to target Node platform dependencies or common platform dependencies. Projects that depend on the browser platform directly or indirectly cannot be included as a dependency of a Node project. And the inverse is true for browser. So really the only change, there hasn't really been a change to the language itself to support Node. We just add a little bit of metadata in the Gren.json file, and then we taught the package manager to exclude dependencies based on that platform setting. And you will see this a little bit more clearly in the demo. And so because of that, there's now a new package called GrenLang Node. And GrenLang Node, the intention behind it is to support all the built-in Node.js APIs that are available. This means things like file system access, calling Unix processes, HTTP backend, HTTP client, all those sorts of things. We are not even close to implementing all those APIs, but what will be available for Gren O2 is kind of like a preview of how this is going to work. Most of the modules in the Node package are based on the notion of subsystems and permissions. So the file system, for instance, is an example of a subsystem. And a subsystem has to be initialized as your application starts up. And the result of that initialization is a permission value. And only if you have the permission can you call the file system subsystem. That's a lot of systems. Again, you will see that more clearly, but that's in the Node package, we're trying to explore what the world will look like if manipulating the file system or performing an HTTP call requires permissions. Is that too much code, or is it just enough? We'll see, but it's an interesting experiment. And again, you will see that more clearly in the demo. A package consolidation was the thing I mentioned, and really what that means is that many of the core packages have emerged into fewer but bigger packages. As an example, GrenLang Browser, Virtual DOM, HTML, and SVG used to be 4 separate packages. Now they're all the same. You can find all those APIs within the GrenLang Browser package. And the main reason for doing this is just that it's easier for me to maintain. The fewer issue trackers, the fewer repositories, the fewer packages that need to be published, the less time I spend on pure overhead. At the same time, having big packages don't really come with a lot of downsides. The compiler doesn't really have to work any harder. The compiled asset size remains the same because of dead code elimination in the compiler. And in fact, having fewer packages means that the package management side of things is faster as well. And then the package manager itself has improved in a lot of ways. So first of all, it's a lot faster. We have a repository called the example projects repo, which contains, at this point, I think around 7 example projects written in Gren. Before the package consolidation changes happened, I measured Gren 01 to spend 45 seconds building all those projects, whereas in Gren 02 we were down to 12 seconds. So that's a huge difference in performance. Whoops. Then error messages have improved greatly. So as an example, in 01, if you were to have one dependency that depended on core version 1 and one dependency that relied on core version 2, this is a made-up example, but in that case, you would simply get an error message saying that something seemed off with your dependencies. Did you try to edit this by hand? If so, revert your changes and try again, which isn't very helpful in a case like that. But in Gren 02, you actually get an error message saying that this dependency wants this version of core, but we've already resolved core to have to be this version. Something is off, which helps a lot when debugging such issues. There's also, the package manager has also learned a few new tricks. The install command now doesn't require an argument, so you can call Gren package install to just install dependencies. If you are trying to build a Gren project within a Docker file or something, having this available as a separate step can be quite helpful. There's also an uninstall command, which lets you remove a dependency. And if you, for some reason, cannot remove a dependency, it will tell you exactly why you can't, which is nice to have. And finally, there's an outdated command that just shows you which packages could be updated to a later version and which are already up to date. And that's the big ticket items. There are more things, and you can read the release notes on Monday to see the language changes of things. But I think that's the important things, the big things that has happened. And I'm now going to show you, at least I'm going to try to show you how we can build a Node application in Gren by re-implementing the echo command. I'm going to try to answer questions at the end, but I saw this question from Joran, so I'm just going to answer that right away. There is no upgrade command yet. So the package manager is going to be in this constant state of improvements. So I'm hoping to add improvements to the package manager along the way. All right, so let's try to build something. So I'm hoping that the text here is readable for everyone. I think that's better. So we're gonna create the echo command. So it's a very simple Unix program. It simply prints to standard out. So the first line of business is to create a new directory. And then we're going to call init. Now fish is giving away all the good stuff here. But we taught the Gren init command a few new flags in order to simplify creating the application you want. So we want to create a Node platform application. And yeah, we can just do this. If we wanted to create a Node package, we could include a package flag. but by leaving that off, Gren init will create a application JSON file for us. So that's how that looks like. Note that there is a new platform field in the Gren JSON file, which is set to Node, which is what we want. So we are going to add a new main.gren file. Just going to add some default stuff here. So this is hello world. We are going to make this like so. And that compiled successfully. And as you can see, this creates a new file called app. So when the Gren compiler sees that this is a Node platform application, a Node application, if you don't provide an output name, it will just create app as the default thing. And it will add like a, what you call it, a shebang line to the top of the generated output, which means, which identifies it as a NodeJS application, which means that we can simply run it like so. Whew. And there we go, hello world. And then there's a warning saying that you should probably compile this with Optimize. Of course, we can do that. Just to satisfy the compiler. Hello world. So that's, now we have a Gren, now we have a Node.js application, and you can run it like any executable, which is nice. So now we're going to make this full-blown, because returning a string is just like the Gren compiler knows how to turn a string into an actual Node application. But in order to implement echo, we're going to need access to the arguments provided to the application. And to do that, we're going to need to make this a full Node application. So I'm going to look into, because I've forgotten how to do these things, which is to say that I haven't forgotten it, but to show off the documentation, to have an excuse. So here is, this is the package website, which has documentation for all the core packages. You'll see there's a Node package that we can click on, and then it will have some explanations. But the important thing that we're looking for is, how do we define a program? So there is a Node program module that we're going to take a close look at. We're going to import Node program. I'm going to take a little, let's type at least. So it has a program that takes a model and a message. Fair enough. So the model is going to be empty for now, and the message is going to be nothing super exciting. We are then going to compile this, mostly so that I can get error messages along the way. So everything for now works correctly. So we are going to have to define a program, which takes in a program configuration, which is a record, taking init, update, and subscriptions. This is what you're used to from Elm or browser applications. So we're going to have an init function, an update function, and subscriptions, which we will, for now, always ignore. So just to make it easier on the eyes, I'm going to pretend that this is an Elm application just to get some syntax highlighting. So the init function is going to return an app initializing task, which in turn is this, yeah, so where does that come from? So the app init task is a task that can only be created at the application startup time. And the reason that we're not just allowing the init function to return a task is because we only want the application itself to be able to define app initialization tasks. And the reason for that is that this is, actually, let me just finish the example. I'll talk more about it. I think that might be easier. Right, so we're going to initialize, and that initialization is going to return an app init task. Yep. We are going to do this. We're going to just return some simple value for this right now. So we're going to say that when the app is initializing, we're just going to start the program. And this is a way of saying that the start program is a way of saying that we don't have any more initializations to make. This is the model. This is the initial model and the initial command. So we're essentially saying that when the program is initialized, here's your model and don't perform any commands. Hopefully this will compile. Of course it doesn't compile because I haven't defined an update, but it didn't give me any other errors, which is good. And the update, and I always forget the order of things, so it's the message before the model. That's nice to know. So message, model, which returns like that. And again, I'm just going to stub this to make it very, just to get this to compile. Let's see if that makes things better. So that compiles, but it shouldn't do anything. Nope, doesn't do anything, which is good. So this is the boilerplate for an application, for a Node.js application. This is like the minimal amount of things you can do just to get the setup correct. Now that we've gotten this far, let's see if this works. Running Gren format. This is something that ideally you should do on save, but editor plugins is not my focus right now. So you can see here, it did format the file, added lines. Everything seems to work correctly. If I sound surprised, it's because I haven't really run this outside of testing. So it's just, yeah. So that worked. So the next step is to actually do something useful. So the echo command outputs to standard out. It prints on the screen the arguments you provided. So we're going to need a way to get arguments. So let's see. There is a node namespace, which should probably be called something else. But this, the node module gives you the option. It allows it provides an app initialization task, which gives you gives you data known to your application at startup time. So the result of an app initialization task is a configuration record, And the configuration records contains the platform you're running on, and this could be, as you can see here, this can be Windows, Linux, Darwin, which is Mac. It also provides CPU architecture, arguments, which is an array of strings, and arguments is what we're ultimately after. But you're also provided the initial values of the environment variables, the standard out stream, the standard error stream, and the standard in stream. So it seems to me that we're going to need to initialize the node subsystem. And by initializing the node system, we will get access to the program arguments and the standard out stream. So in order to do this, in our init function, we are going to await we're going to await the node initialization. And when that is done, we will have access to arguments and standard out. Let's see if this compiles. So in our model, we want the starting arguments, the program arguments, and the standard out stream. Now I said in the presentation earlier, I said that the node package is built around the idea of subsystems and permissions. The standard out stream is returned as a result of an app initialization task. An app initialization task can only really be used at the top level, right? The application's init function can return an app init task, but app init tasks aren't useful anywhere else. So it's the application that defines which subsystems is initialized. So in this case, we're initializing the generic node subsystem, and that gives us the standard out stream. And hopefully, what this means is that only your application has access to standard out. If you want to give any other code the option of writing to the terminal, you will have to pass the standard out stream to that code. And so the standard out stream, in this case, acts as a sort of permission for what parts of your code base can write to standard out. So in our initialization task, we wait for the node subsystem to initialize. Once it has, we extract the arguments and the standard out stream, and then we start our program. And then, just to see that we have started, we are going to try to print something to standard out. So in the stream module, we can see there's a function called send, which takes a stream and bytes, random bytes. So we should be able to do send to standard out, and then that takes bytes. Which is now in the core package due to packet consolidation. So for bytes, we can encode string. That seems easy. So that would be So that, yeah, wrong. I'm performing a line demo. Having statically typed language does save your bacon. So there we go. Now, you might think that having to define a byte encoder in order to be able to write to standard out is kind of heavy-handed, and I agree with you. This is the beauty of having a preview language, is that I haven't actually written a lot of applications with this until now. So there will be rough edges in the Node package, but hopefully those will be smoothed out over time. It's when you use things, it becomes apparent the shortcomings of a package. All right, so this is how you define, so this is how you write to standard out. In order to write to standard out, you're going to need access to standard out to do so. And I can see now that we don't actually need to store anything in the model at all. So we're not going to do that. But if you wanted to be able to write to standard out successively, or if you wanted to write on standard in order to write to standard out, you would of course store the standard out string in the model itself. But we don't actually need to do that for echo. So what we need to do now is to, well, essentially just join all the arguments. So arguments is a list of strings. So that should just be, wait. I guess joining them all should work. And if you haven't noticed, I did not prepare for this before the stream started, so I'm figuring this out as I go along. So we got a, yeah, that's because of this. Right, so interesting, it compiled. So can I do hello you? Right, not entirely, and that makes sense. Let's see. That makes sense because when the array of arguments includes the runtime that is being used, like the executable that's executing a program, and the arguments to it. So we're running Node with this script, and the arguments we're looking for is hello you. So we're going to need to remove the first two. So let's see. We're going to take the args. We are going to, let's see. What's it called? It's drop left, I believe. There we go. Yeah, drop first. So we're going to drop the first two arguments. Then we're going to turn that into string. And then we're going to add a new line to the end. Aren't we? Does this work? Nope, that makes sense. There you go. Hello, you. Yeah. And then formatted. So that wasn't all that bad. And that's the demo I had. But if you're curious on what a more involved example looked like, the website might be a better idea. Then we have, nope, on the Gren GitHub, we have a repository called example projects. One of those example projects is a Gren implementation of cat. Cat has to do a bit more work because it actually has to read file before it outputs them. And you can see how that happens here. So that involves another subsystem, which gives you access to the file system. And then you need to open the file in order to do stuff. So you can take a closer look at that if you want to see a more involved example. But yeah, that's how you write Node.js applications in Gren. So before moving on, I'm just gonna check if there are any interesting comments. Yeah, so there's a question about there not being a type difference between standard in and standard out. So in my research on this, you can in fact, in normal applications, you can in fact listen to standard in, and you can, or no, sorry, write to standard in and listen to standard out. Not sure if there's any good reasons to ever do that, but it seemed very difficult to create an abstraction that was airtight. But again, the Node package is experimental. It probably will change going forward, both to smooth out rough edges and just, fix things or improve things. So it's very much a work in progress. Aaron asks if there's a demo of a Gren program that writes Gren programs. No. So with that out of the way, that was Gren 02. That was like the big thing with Gren 02. There are other interesting things as well. I showed the formatter and the Node.js support, faster package manager, a few language features. But really, this is it. This is the big thing. This is the thing that separates Gren from other things. Now, Gren has a strict 6-month release cadence, which means that 03 is coming in June. What is the plan for 03? The 03 release is called Testing and Debugging. That's the theme. And during the next 6 months, I hope to provide an official test framework. I want to add source maps so that you can actually debug Gren code. I want to improve the code generation in order to provide better debugging support, but also improve performance. And finally, add missing features to GrenLang browser and GrenLang node. And I think Aaron is also planning on to continue working on Gren format to make that even better than this today. So digging into this, having an official test framework for Gren, I think that's like the missing piece when compared to Elm. That's the one thing that hasn't been ported over yet. In addition to an entire community, but baby steps. So the test framework itself will be based on Elm test. It will be a port of Elm test because in my mind, Elm test really is it's the creme de la creme of testing frameworks. It's a fantastic thing. There's no reason to reinvent that particular wheel. I do not plan to have a Node applications that generates the test harness for you. You're still so the official testing framework will require you to write the entire suite, the test suite tree yourself. But in order to do so, you will need some way of extending a project, or at least I think so. Like, it would be nice to define a local project that extends the project you're working on. And then you just add the test framework dependency and take things from there. It might also be interesting to take a look at defining project local scripts. So essentially what I mean by that is having some way of performing Gren run and then some qualified function. That would allow you to have like development plugins by downloading a dependency and then using Gren run to run that dependency in your local project. And it would enable having something like Gren run test.run or something. But this is just me thinking out loud. It might not end up this way at all, but that's my current line of thinking on how testing should work on Gren. Gren test will just be a framework, and you can include that in an extension project, and then run your tests using a Gren command line sort of thing. Maybe. The other big thing for O3 is source maps and code generation. So this is a screenshot of the Gren to do MVC example project from the dev tools in Safari. So it is possible to step-by-step debug a Gren application, but you have to deal with JavaScript source code, and you have to deal with a strange call stack on your left. You need to understand how the runtime represents things like custom types in order to make sense of things. And ideally, I want this to change. I want Gren to have a proper step-by-step debugger in backend as well as front-end applications. So the first thing I want to add is source maps. And source maps is a way to teach the dev tools how the compiled JavaScript maps to your target language. Essentially, it's a way of getting Gren source code into the debugger and allowing you to set breakpoints in Gren source code. But that on its own is not going to give you a good debugging experience, because you still need to be aware of how the Gren runtime works in order to make proper sense of things. So, for instance, custom types is defined as JavaScript objects, which has this $ symbol saying what constructor the object was created with. Ideally, I would want this to be like a proper JavaScript type, so that you can actually see the type involved, the custom type name, in addition to the actual constructor being used, and have that be like very clear. One thing that works in Gren's favor is the decision in 01 to use actual JavaScript arrays instead of linked lists. And so arrays in Gren are just JavaScript arrays and shows up properly in the JavaScript debugger. So that helps. Another thing is to clean up the call stack. So you can see here that when you call due to how currying works, when you call a function that takes more than 2 parameters, Gren inserts a little bit of magic to be able to have function calls works in the presence or absence of currying. So when you call a function that takes 2 arguments, and you call it with 2 arguments, you pass the actual function itself along with its parameters to an A2 helper function. And this shows up in the call stack as an A2 call. And then due to how functions are defined, the actual function being called will show up as an anonymous function. And you will see this when you hover over a function in the debugger, that it shows up anonymous function, which doesn't really help you a great deal. It makes it harder to actively explore what is happening. Another downside to this is that all these A2, A3, A4 calls, they stack up. So if you have like a very long call stack, the chances of triggering a Stack Overflow exceptions are bigger in Gren than in JavaScript because of all these interleaving currying helper things. There is a third party, there is a tool for the Elm community called Elm Optimize Level 2, which as an optimization actually removes all these A2 calls when it figures out that you can perform a direct function call. And that of course improves things from a debugger point of view, but also it improves performance. And I think it's, you know, in the order of depending on your project type, it can be anywhere from 10% speed improvement to 25, 30%, with the average being somewhere in between those two extremes. So in addition to improving the debugging story, it actually also improves performance. And because your call stacks become shallower, it actually also improves safety, stack safety. Yeah, so that's the idea for O3, and that's at least that's what I'll be focusing on for O3. But I wanted to mention this at the end, that Gren is very much open for contribution, and there are many ways to contribute. The first way, and perhaps the simplest way, is just to use it. Right? Just try out Gren, try to make a package, try to write a project, try to write a Node.js application. If you find any bugs, then report it, and if you think things could be improved, or if you like it, or if you don't, just give feedback on it. Also, join our Sulip channel and give feedback on language proposals. I try to explain my ideas before I start implementing them in Sulip first, and hanging out in Sulip is a great way to just keep tabs on the development of Gren. Another way of contributing is to talk about Gren, write about Gren, spread the word to other people. And you can also start creating packages. Like, one thing that I would love to see someone do is, and I'm saying I would love to see someone else do it because I don't think I have the time to do it myself. But having like a command line flag parser thing in order to create like really cool CLI applications, Gren, that would be awesome. But if you're feeling bold, like if you think if you really want to contribute, you can just send me a message and ask if anyone is trying to implement the HTTP server API for Node. Right? If you are motivated to do these big things, either in the platform APIs or in the compiler itself, talk to me, and we'll see what we can do. And if you don't have time for any of this, or if none of the above things are your thing, considering sponsoring me on GitHub. For 2023, I hope to set aside all the sponsorship money in a separate account, and hopefully someday that money can be spent on, I don't know, sponsoring conferences or hiring someone for a month to work on stuff, if the amount of money ever grows that big. So there are a lot of ways to contribute if you want to do that. That's really all I had. So I'm gonna hang around. That was all I planned to do. I'm gonna hang around for 5 minutes and just answer questions if they show up in the comment section. So let's do that. So Yurin asks about the code generation changes that I plan to make. Would making it proper JavaScript types not decrease performance? Actually, it probably would. Well, it depends on how you generate the code. Um, the problem with how custom types are compiled right now is that if you have a custom type with 4 constructors, and each of those constructors, or 4 or any amount, any amount of constructors more than one, if those constructors all contain different number of arguments, then the JavaScript engine will consider all those constructors separate types. And what that means is that every time you pattern match on that one custom type, the JavaScript engine will see that you are potentially handling many different kinds of types, and that will generate worse code. And since custom types really is the bread and butter of Gren, that can actually trigger bad performance in many ways, in many cases. So in addition to, by creating a custom type, which if all constructors were to create the same type, but with some fields just not set, then you would get one type, which would generate better performance, might increase memory usage a little, but the performance to generate code would be better. And at the same time, the JavaScript JIT would actually know the type of the custom type. And so you would get that information as well. So Aaron is wondering if browser web inspectors, is it, so if I understand your question correctly, you're wondering if it's possible to teach the dev tools how to represent a type in the dev tools itself. And I believe that is possible, but I'm not sure if you can do it, if you can implement it once for all browsers. I know ClojureScript had this the ClojureScript community at one point, if it doesn't still, had a tool for doing just that. So it was a tool for Chrome specifically that taught Chrome that a ClojureScript vector can be represented as it can be formatted as an array in the DevTools. So it might be possible, but I'm not sure it's possible in a cross-platform way. But that's definitely something to look into. So Mario, you're wondering if I'm planning to introduce the subsystem permission setup for any existing LN APIs, like the HTTP API. I might. Currently, I consider the Node package to be kind of an experiment in that regard. If that experiment turns out well, then it would be natural to extend that setup to other parts of Gren. But currently, I'm trying that out in the Node package, and we'll see. Jörn asks if what I'm saying is monomorphism. Yes, that would be it. Monomorphism would also mean that if you have a custom type taking in generic arguments, that you would actually create a new type for every generic value you give it. And that's not what I'm saying, but representing multiple custom type constructors as a single type is a sort of monomorphism, yes. The Node package doesn't support HTTP yet. There just wasn't enough time to get that far. So let's see. So I've skipped a question from Steven. So I'm drawing a blank. So Stephen is asking if there's any recommendations on writing a library for a Node platform application. Like how would you test such a library? I should be able to answer that question, but I'm currently drawing a blank. If you could send me that message on Sulip, then I will give you an answer in due time. Aaron asks, what was involved in implementing better errors for project dependency conflicts? Mostly just retaining information for later steps. I think the reason it wasn't done was just because it wasn't prioritized. It wasn't difficult to do. It took some time because I didn't. Yeah, it just took some time to understand the code, and then was relatively straightforward to implement. Right. So I think that's all. Yeah, I think that's it. So thank you all for coming to the for watching the stream, and as mentioned briefly, join the Sulip if you want to discuss more. Come with suggestions for further improvements. I hope to see you there. Thank you.